Good afternoon and welcome to the session on transport and infrastructure projects. My name is György Dán. I'm professor of teletraffic systems at KTH, and I have the pleasure of chairing this session today. In today's session, we will present 3 demonstrator projects within Digital Futures. These presentations will be followed by an approximately 5 minutes long live Q&A session. You are very welcome to send in your questions during the presentations through the chat, or you can ask your questions during the live Q&A session. The first presentation will be about the Digital Futures Drone Arena and will be given by Luca Mottola, who is a senior researcher at RISE. The second presentation will be about the IHOOS Project, which deals with improving air quality and health risk forecasts by data-driven modeling of traffic and atmospheric environment, and will be given by Christer Johansson, professor at Stockholm University. The last presentation is about the project Susan's Ride on Campus 2030, which deals with the digitalization of the road construction industry and will be delivered by myself. And with this, I leave the floor to Luca.
Welcome, everyone. My name is Luca Mottola. I'm a senior researcher at RISE Kista, and I'm really excited to give you a glimpse of the work I'm doing with Eeri Lampinen from Stockholm University, as well as with Kia Hook, Rachel Garrett, and Kristina Popova from KTH, on an initiative we called the Digital Futures Drone Arena. I'd like to start showing you a video of an experiment carried out in an earlier project to study the unfolding relationship between a theatrical actor and a flying device. As you can see in the video, the actor's bodily expressions are influenced by the drone movements in a developing connection of sorts. The objective of this earlier project was to study how humans interacted with drones on a peculiar scenario that was an opera stage. But that was a one-off installation, whose access was limited to the project partners. In this project, we want to push the envelope and go way past this point. What we want to achieve here is the creation of a concrete as well as conceptual platform where the key players in the digital transformation and society join in a conversation about the role and impact of mobile robotics, autonomous systems, machine learning, and human-computer interaction. For us, this takes the form of a novel aerial drone testbed where drone competitions take place periodically to understand and explore the unfolding relationships between humans and drones. To make our project idea more concrete, we set out to achieve 3 key goals. First is to build a novel aerial drone testbed studied to facilitate application-level functionality rather than being focused on the low-level control mechanisms like existing drone testbeds. Our testbed is designed to stay past the end of the project with a changing focus on different technical and thematic angles over time. And to do that, we'll be releasing as open source all the hardware and software components, and the testbed in itself will be conceived to make it easier to replicate the testbed infrastructure at different sites, depending on the future needs and the future opportunities. Using the testbed, we will organize 2 competitions within the course of the project. The competitions will involve multiple teams that are tasked to realize functionality that somehow push the state of the art. The first competition will be traditional in scope, and I'll talk more about that later. In the second competition, we will take inspiration from the postures, the posing, and the aesthetics of fashion shows, and push for gesture-based semi-autonomous control that will enable the exploration of even richer movements. Based on these 2 competitions within the course of the project, we will conduct empirical investigations of the human-drone interactions. And this will include observations, interviews, and microsociological video analysis that will inform the future competitions in the drone arena and will be useful to develop insights from the movement-based explorations of the activity of drone piloting. This will be instructive to design human-drone interactions that promote well-being and richer experiences. As for the first goal, we are currently building the testbed that will form the foundation for the project activities. We are using state-of-the-art drone technology, including, for example, the BitCraze Crazy Fleet, which is an incredible nano-drone platform rich of features and capabilities, together with a sophisticated infrared localization system. And these two together will enable amazing choreographies like those you can see in the video on the slide. We are at the same time preparing for the first competition, which is going to be similar to a hackathon and open to everybody, students, researchers, practitioners, and technology enthusiasts. The goal will be to fly through an obstacle course in the shortest amount of time, and we are securing the KTH nuclear reactor hall to run the competition on what we think is a unique stage. The dates are not fixed yet, but most likely the competition will run sometime in June next year. You're welcome to check out our website at dronearena.info to stay up to date. Remarkably, we are not aware of any effort like ours that lies at the intersection of mobile robotics, autonomous systems, machine learning, and human-computer interaction. Achieving the three goals I described before in a coherent manner requires us to break technological and cultural silos, really walking in uncharted territory. Beyond the two specific competitions we'll run in the course of the project, we think that our work will have relevance in a number of other contexts and domains, such as when drones are used by rescue teams for visual inspections, and may, for example, even influence upcoming regulations on the use of civil drones. So this concludes my introduction to the activities of the Digital Futures Drone Arena. I'll be happy to answer any question during this event, or feel free to drop me an email if you want to know more.
Thank you, Luca. The second presentation is about the IHOOS project and is delivered by Christer Johansson. Please, Christer.
The IHOOS Project is a cooperation between Stockholm University, Royal Institute of Technology, and the City of Stockholm, represented by the Environment and Health Administration. Air pollution is considered the largest environmental health risk. So it's both long-term exposure during a few years or even decades, or short-term exposure during a few hours or a few days cause mortality and morbidity due to cardiovascular and respiratory diseases. Short-term exposure also increases the hospital admissions due to cardiovascular and respiratory diseases. As you may know, more and more people suffer from asthma and allergy due to exposure to high birch pollen levels, especially during the spring. And at the same time, some different key air pollutants are high, also during the spring. So both air pollution and pollen levels are particularly high during the same time period. And high levels of air pollution can actually increase the adverse effects of pollen exposure. So we need to consider both air pollution and pollen when we look at the short-term effects. So in Stockholm, we have developed a health risk, air quality and health risk information system that forecasts the air pollutant and pollen levels for the next few hours and also for the next few days. The information is presented in a mobile phone app on maps, detailed maps over Stockholm. And there is also an individual health diary in this mobile phone where you can record your own health status and compare with the air pollution and pollen levels and see what causes the main adverse health risks for each person. So this forecast system is based on meteorological forecasts over the whole of Europe, European emissions and transport of air pollutants, and also forecasts of the emissions of air pollutants within the city. It is also based on real-time air quality monitoring data. So here you can see the transport of air pollutants from Central Europe with the winds up to Sweden, in this case Stockholm. So for some pollutants, this transport can be a very important part of the total air pollution level in Stockholm. These calculations, these forecasts are based on a European system using 7 different air quality dispersion models and taking the average of those models. So for every hour during the coming 4 days, you can see how the air pollutant levels are vary during the whole Europe. Then for Stockholm, we also need more detailed information on the air pollutant levels down to 100 by 100 meter level. So here you can see how the air pollutant levels change from 1 hour to the hour, depending on the emissions and the local meteorological conditions. You can even follow how the air pollution levels vary on different streets. You can see that on some hours, levels are higher on one side compared to the other side of the street. And this is also forecasted for the next hours and for the next 3 days. And since you have the information for several different air pollutants, you can calculate the integrated total air quality health risk associated with the air pollutants, and also taking into account the exposure to pollen. In another project, the Swedish Transport Administration wants to predict how speed limits could be reduced due to the high air pollution levels in the next few hours. So also in this case, you need to have forecasts of emissions from road traffic and forecasts of the air pollution concentration that these emissions cause. The contribution of IHOOS is to improve the accuracy of these forecasts. As you may understand, there are many uncertainties associated with these calculations. So we need to improve the accuracy in both the health risks due to air pollution and also the accuracy in the emissions along different roads within the area. And how can IHOOS contribute to this? We will use machine learning, and the input to the machine learning will be both forecasted and historical air pollutant levels from different monitoring stations, and also meteorological information and other information that might be relevant. We will also have a data-driven traffic modeling to predict the spatial temporal distribution of road traffic emissions and the concentrations. Today you can see screens along streets informing about the where you can find information about the air pollutant levels and the health risks associated with those. Within IHOOS, we will also develop a website with detailed maps of air pollutants, and where you also can see the improved forecasts developed within IHOOS. So this system of air quality health risk has been developed with several partners involved. including the city of Stockholm and the Swedish Transport Administration. The project has also been part of an EU project within the Horizon 2020 program. And finally, I want to acknowledge my colleagues, Xiao Liang Ma at the Department of Civil and Architectural Engineering at the Royal Institute of Technology, and Magnus Engert at SLB Analys, Environment and Health Administration in Stockholm. Thank you, and I'm happy to answer any questions.
And finally, I will present the project Susan's Ride on Campus 2030.
Susan's Ride on Campus is a project in cooperation between three co-PIs. Nicole Kringos is a professor at the School of Architecture and Built Environment at KTH. Martin Törngren is a professor at the School of Industrial Engineering and Management. And myself, Jörg Dahn, I'm professor at the School of Electrical Engineering and Computer Science. The project deals with sustainable smart road infrastructures, but opposed to many projects that deal with mainly steering the flow of vehicles on roads, here the focus is predominantly on making the construction, operation, and maintenance of roads more sustainable and more smart. Our motivation is that road construction today is far from optimal, and this results in rutting, cracks, and potholes. Now, rutting, cracks, and potholes are not only unpleasant aesthetically, but they also harm traffic safety. For example, they can cause aquaplaning, and they also result in increased maintenance needs. Hence, road maintenance becomes very expensive. Estimates show that today the road maintenance costs about $1,000 to $20,000 per kilometer per year. And part of the problem is that road maintenance today is reactive. Maintenance is carried out in response to rutting, cracks, and potholes, not in order to prevent those from happening. Our key observation is that data could be collected and used during construction and operation. At this background, the objective of Susan's Ride is to demonstrate the potential impact of digitalization on road construction, road operation, and road maintenance. The idea is to use data-driven construction, operation, and maintenance, that is, use the data that can be collected during the construction of the road and the operation for improving the maintenance of the infrastructure. And we also aim to identify the lacking systemic structures, how data could be used in this economic environment between many different stakeholders in the road construction, operation, and maintenance industry. Our methodology focuses on three phases of road construction, operation, and maintenance. The first phase is road construction itself, where we plan to demonstrate the potential of real-time decision support for improving road construction, in particular the compaction process that is the underlying fundament of all paved roads. The second phase is predictive maintenance, where we aim to show how the data collected during compaction and construction can be used for predictive maintenance, thereby reducing the maintenance needs of paved roads. The third phase is the actual operation of the road, where we plan to demonstrate how the traffic behavior can be adapted in response to the state of a road, which we would know from the data collected during the construction and the operation phases. We plan to achieve these through relying on data collected during construction and operation, and through algorithms developed for using these data. So we plan essentially to build digital twins for the road infrastructure, where we store data collected during construction and operation, And we use predictive algorithms and machine learning for optimizing both the construction process and the maintenance process. We plan to develop 3 use case demonstrations. The first demonstration will show how an operator could receive real-time feedback through augmented reality about the compaction process during road construction. This will be a simulated demonstration. The second demonstration will be that of road predictive maintenance through the data collected and stored during the construction phase. This will be a simulated demonstration. The third demonstration will be the adaptation of the behavior of autonomous vehicles coordinated with the state of the road, which we would be aware of again through the data collected during construction and the operation phases. And this will be a mixed simulated and real demonstration. We plan to cooperate in this project with a number of industrial stakeholders, including Trafikverket, the Swedish Road Transportation Authority, and construction companies. The demonstrations will partly be carried out at KTH, on the KTH main campus, where we are planning to use the existing communication and compute infrastructure and assets contributed by partners. And here we will then deploy a reference implementation of the solutions that we will develop in the project. This will be in cooperation with other ongoing projects, sister projects, including the Campus 2030 project and the EDI project that are currently ongoing at KTH. Overall, we believe that Susan's Ride on Campus paves the way to sustainability through reducing the carbon footprint of the road construction industry. The numbers show that the reduced maintenance could reduce operation and maintenance costs by up to 95% if, for example, only cracks were detected early before major damage happens to the roadbed. And they would also contribute to improved traffic efficiency through better roads, which then contributes to economic and social sustainability and better traffic safety. If you would like to know more information about the project, we invite you to visit our webpage. And you can also obtain more information about our sister projects, for example, EDI.
And now we have about 5 minutes for a live Q&A session. So I invite everyone to ask their questions live or through the chat.